Alright, this is Algebra Lesson 5, Domain and Range. Students will express relations as a table, graph, and as a mapping diagram. So we're going to learn this this word called function. This is really important in math because it makes, we use as logic in math. We use this word called function. That's an F, by the way, not, it looks kind of funny. And this, let me just explain what a function is, okay? Let's pretend I had this machine, okay? Be any sort of machine. I have like a place that I make food, okay? And if I put ingredients in the machine, let's say I put flour, sugar, butter, eggs, chocolate chips. Put all these ingredients into a machine. What's going to come out of the other end? Chocolate chip cookies, right? If I put all those ingredients in, am I going to get out a cow? Is a cow going to pop out of my machine?
No.
No, it doesn't. It's not going to produce two things. It's only going to produce one thing. What's the one thing I'm going to produce?
Chocolate chip.
Good. Even though I had 5 ingredients, I'm still going to get chocolate chips. Does that make sense?
Yes.
Good. So, let's say I put in corn and carne asada and some tomatoes and jalapenos and cilantro and onions, salt and pepper. Put that in my machine. What am I going to get out? Tacos. Okay? Right? The corn.
I knew that.
Right? I'm not going to get out chocolate chip cookies, right? Does that make sense?
Yes.
Okay, good. So you have to think about a function in math is the same thing. I'm going to put ingredients into my machine, meaning I'm going to put numbers in. I could put in a bunch of numbers all at once, but how many numbers am I going to get out? Only one number, only one output. Does that make sense? If it's not a function. So that's why it's called function, because that's the function. If it's doing more than one, it's not a function. It doesn't work correctly. It's not logical, right? It's not logical that I put ingredients in for chocolate chip cookies and I get out a camel, right? Right?
That'd be pretty cool.
That'd be cool. Okay, so make sure that you're thinking in those terms today. That's really important. Okay, so that means for every, we only have one output. For a function to exist, how many outputs do we have? One. Turn to your neighbor, how many outputs can you have only? One. Okay. Okay, here we go. So, these are the steps. That was a bit of a sidetrack, but it's really important that we understand that. And we're learning about the logic of math now in functions. Here are the steps. If you're on the video, pause it now. Here we go. Number 1 and 2. So I'm going to get a bunch of these numbers and inputs. Just watch right now. You're like, what is all this? This looks crazy. Okay? Number 1. Let's say I had all these numbers. -6, 4, -2, 3, 2, -4, 5, 6. These are all coordinates or ordered pairs. Okay, so -6, 4. This is an x and this is a y. On -2, 3, this is an x and this is a y. 2, -4, this is an x and this is a y. And 5, 6 is an x and this is a y. Okay? You follow me so far? X's and y's? Okay?
Yes.
First thing I want to do is I want to organize things because all my x's in math are my inputs. It's the ingredients I put in. The y's are the outputs. Okay? Which ones are my inputs? X's. Which ones are my outputs? Y. Good, okay? So, let's figure out what my ingredients are. So the first thing I always do is I try to make a table of x's and y's. And I think, what's my smallest x? What's my smallest x? -6. Okay, let's put that one first. And what's the y that is the output when I put in -6? 4. Okay. What is the input? Was the next smallest input? -2. Oh, look, it's kind of already in order. 3. Next one is 2. -4. And next one is 5, 6. Okay, so this is a table showing me what my inputs and my outputs are for each input. Meaning, if I put in -6 in my machine, what do I get out of it? A 4. If I put in -2, I get a 3. These are already in order, so it's a lot easier to do, okay? Next thing we're going to do is this thing called we're going to graph it, okay? So you can see what it looks like. So I'm going to make like a quick little graph on my paper, on my homework, and I'm going to graph these. So I'm going to go -6, 4. If I go to -1, 2, 3, 4, 5, 6, and up 4, I get a point right here. And then if I were to go to negative 2, 3, I get a point right here. And then if I were to go to 2, negative 4, right here, I get a point here. And then if I were to get 5, 6, I go 5 and up 6. I get a point way up here, right? As you can see, if I were to connect the dots here, just even like loosely, not as a line, the line is always moving, you see? It's never having 2 points. And we'll talk about this thing called the vertical line test. But we're going to draw a graph. I want you to look at the graph today, okay? And then the last thing you're going to do on each example is draw a mapping diagram, which is making 2 boxes. One's going to be X's and one's going to be Y's, okay? This is called the mapping diagram. These are X's and Y's. Or we call the X's, what are X's? Inputs. Out, and my Y's are called what? Thank you. Okay, what's the smallest input again? Next smallest input. Next smallest input. Next smallest input. Good. What's the smallest output? Next one. 3. Next one. Next one. Okay, good. So if let's start with negative 6. If I put an input of negative 6, what will I get out of negative 6? Negative what? 4, right? So I'm going to draw an arrow from negative 6 to 4 like so. Okay, just like that. Okay, if I put a negative 2 in my machine, my math machine, what do I get out of it? Good, so then I go draw an arrow from negative 2 to 3. Okay, if I put a 2 in, what do I get out? Okay, negative 4, so I'm going to draw an arrow up this way, and then last one, 5, goes to 6, of course, and that's it, okay? And what we're doing is looking at all these different ways to look at it. For every input, there's only how many outputs? 1. There's only 1 output. If we have 2 outputs, it's wrong. Sometimes you're going to do this, and let's say we have a 5, and you'll notice 5 will produce 2 outputs, and then we know it's not a function. But this is a function because there's only 1 output per input, okay? So we'd say, yes, this is a function. Okay, watch me do number 2. This is a function, okay? Period. Boom. Okay, number 2. First thing I do is make an XY table. So, okay, drawing my x's. What's the smallest x up there? What? 3. Okay, what's the y that's paired with 3? 5. Next smallest x? 3 what?
2.
Next smallest x? 4, 6. Next one? 5, 2. Anything else?
5, 3.
5, 3. Okay, good. Okay, so now we just organized. Now I'm going to draw a graph, okay? So on each problem you're going to draw a graph when it asks you to. This is like the basic stuff, and then it's going to ask you conceptual questions tonight. So we're going to go 3, 5, 1, 2, 3, 4, 5, 6, 7, 1, 2. So we got 3, 5, draw a point, boom. Next one, 3, 2. 1, 2, 3, 2. Uh-oh, I'm drawing a graph that looks like it has 2 outputs. 4, 6. 1, 2, 3, 4, up 6. Looks like I'm going to go up to here. Okay, 5, 2. And 5, 3. Okay, and my graph kind of looks kind of weird, right? It kind of looks like this.
Yeah.
Right? Isn't that weird? Okay, why is it doing that? It's because if I were to put an ingredient such as 5, how many outputs do I get? 2, right? Let's say I put in ingredients to make cookies. I'm getting chocolate chips and tacos. Does that make sense? Is that logical? No, so this is not a function. Why is it not a function? How many outputs do we have? 2. Okay, so we have to finish by showing the mapping diagram. So we're just going to draw that really quick. So I'm just drawing a mapping diagram. Okay. So again, what's the smallest x? 3. Next one. 3 again. Next one. Okay, so since we had 3 twice, we're only going to put in 3 once. Okay, then we had 4, and then what's the next one? 5. Okay, so what are the 3 inputs we have? 3, 4, and 5. Those are the 3 ingredients we had. Okay, what happens if we put, or what are the outputs? What are the possible outputs? What's the smallest?
2.
Okay, next output?
2.
We already have a 2. Okay,
3.
3. Next output?
5.
Anything else? Good. Okay, good. So if I put in a 3 into my math machine, into my function, what output do I get? What? 5, and then what else? 3 goes to 5, and then what else do I get out when I put a 3 into my math machine? 2. How many outputs is that?
2.
Is that a function?
No.
No. What happens if I put a 4 in my math machine? What do I get? 6, okay. Anything else? No. Okay, so that one's good. 5, what happens when I put a 5 in? And then what?
2.
Good. Okay, is this a function?
No.
No, this whole thing is not a function. Why is it not a function? Because we have more than one output. No, this is not a function. And we would write this as a sentence. Because no, this is not a function because there are more than one output. Or there is more than one output. One output. That's it. Okay, that's how we do it. Any questions? Okay, so this lesson is really about organizing numbers into tables as a graph and as a mapping diagram. Okay, does that make sense?
Yeah.
And then tell me, is it a function? We know it's a function if it has one output for every input. Okay, so I'm going to pause it right here. I want you to talk to your neighbor. 1 cell 2 is about number 1. And 2 cell 1 is about number 2. Ready, set. Okay, continuing on. Let's do... Let me see what I want to do here. Let's do number 3 here, okay? Here we go. Write this down. The first thing we're going to do is... I'm going to hide number 4 because I don't want to deal with number 4 today. The first thing we're going to do, to your neighbor, tell them what's the first thing you want to do. Okay, we're going to define our x's and y's. So remember, these are x's, y's, x, y, and so forth. So you don't have to write all the numbers down. Let's just start with making a table, okay? So I heard some people say make a table, so let's go do this, okay? Making a table here. Okay, so I'm going to draw a vertical line. Looks like kind of like a cross. We got an x and a y. And so what's the smallest x up there? 0, right? So what number is paired up with 0? What's the output when I put a 0 in? 1. What's the next number? What's the output? Good. What's the next number? What's the output with the 2? 4. Good. What's the next number? 3. What's the output? 1. Or is there any more? What?
4.
And then what's the output? 4. Good. Okay, good. So now we just made a table, okay? Next thing I want you to do is we're going to make a graph, okay? So we're making a graph right now. Okay, so we're going to plot these 0, 1. We're going to plot the first point right here. Then we have 1, 3, so it's going to be 1. Let me make some dashes. So there's going to be a point here. Next one is 2, 4. Should be right here. Next one is 3, 1. We're doing this together, by the way. Hopefully you're following along. Next one's 4, 4. Okay. Do you notice how this graph is moving, but there's no overlapping numbers? Are you noticing that from left to right? Okay, we use this thing called a vertical line test. Is there any time that the graph touches this ruler twice? No, it doesn't. It might go up and down really quick, but does it touch it twice? No, look at the last example. Look at number 2. I'm sorry, I'm going to go back to number 2. Get back there. Did I get there? Oh, I don't have it. Remember, look at number 2. Does it touch twice when I do the vertical line test? On number 2, remember number 2 in your notes? Does it touch twice? Yeah, it does. So we know this is the function right now. Okay, last thing we need to do is draw a mapping diagram. So I'm going to draw a couple of rectangles. Okay. First ones are x's, next ones are y's. Okay, what's the smallest x? What's the smallest input, everyone? 0. Good. What's the next smallest input? Next smallest. Next one. Next one. 4. Good. Okay. What output do I get when I put in, or what is this? I'm sorry. What's the smallest output? Next smallest? Good. Next smallest? Next smallest? Are there any more? No. Okay, good. So now we're going to map which way they go. What happens when I put a 0 into my math machine? What do I get out when I get a 0? A 1. So I'm going to draw a arrow from 0 to 1. Okay, what happens when I put in a 1? Okay, good. What happens when I put in a 2? What happens when I put in a 3? What happens when I put in a 4? Good. Is this a function? Yes or no? Turn to your neighbor and discuss really quick.
Yes.
Tell them why is it a function. Okay. So what do you think, kids? Is it a function? Yes or no?
Yes.
Why is it a function?
Because the input.
There's only one output for every input. Even though there might be, even though there's the same output sometimes, for every time you put an ingredient in, there's only one output, okay? So even though 3 and 0 produce a 1, it's still the same thing. Like, I can make cookies with all my different ingredients, or I could buy the package of those little square cookies, you know what I'm talking about? You break off the cookies, right? Do I still get chocolate chip cookies either way? Yeah, you still get the same product, it's just a different way to do it. Does that make sense? Okay, good. Next one, I want you to go to number 6, last one, okay?